We wrote a system of equations to find the quadratic rule for a sequence, and we can also solve a system of equation using matrices. So I want to review really quickly matrices and what they do, and then show how to do this. It's a very quick and simple procedure and a good use for matrices. So first of all, if we look at these two matrices here, a matrix is just an array of numbers with rows and columns. We state the dimensions as rows times columns. You can think of roses climbing up the columns. I don't know if that helps. So this is a 2 by 2 matrix, and this is a 2 by 2 matrix. These are known as square matrices. And we can multiply two matrices as long as their inner dimensions match when they are side by side. So in other words, the number of columns in the first matrix matches the number of rows in the second matrix. And the way we multiply is we take each row times each column. So there's going to be 4 multiplications take place in this matrix because I have 2 rows and 2 columns in each matrix. So it's going to be row 1 times column 1, row 2 times column 2, row 2 times column 1, row 2 times column 2. And the way I multiply is I multiply pairs of numbers and add them. So this is going to be 2 times negative 2 plus 2 times negative 2 plus 7 times 1. This is easier to show when I can point things with my fingers. When I figure out that value, that's negative 4 plus 7, which is 3. So what I'm going to end up with is another 2 by 2 matrix, and this just to show you here, the outer dimensions will give me the dimensions of my new matrix. So I'm going to end up with a 2 by 2 matrix, and the first element will be 3. First row, first column goes in the position here that is the first row, first column. Now I'm going to do first row times second column. So I'm going to say 2 times 4 plus 7 times 5. So once again, 2 times 4 plus 7 times 5. And that ends up being 8 plus 12 is 20. Or sorry, it's not 12. 8 plus 35 is 43. Woo. Okay, so there's 43. All right. Now, the next thing I do is second row times first column, and then the second row times the second column. So negative 3 times negative 2, so negative 3 times negative 2 plus 3 times 1. So that would be 6 plus 3 is 9. Hopefully I don't make any other stupid mistakes. And then negative 3 times 4 plus 3 times 5. Negative 3 times 4 plus 3 times 5. You're kind of going around the corner as you multiply. So that's negative 12 plus 15, which is 3. So here is my product matrix. Okay, let's do another one. I'll go through these a little more quickly. This is, remember, rows times columns. This is a 1 by 3 matrix. And this is a 3 by 2 matrix. So this has 1 row, 3 columns. This has 3 rows and 2 columns. Once again, since the inner dimensions match, then I can multiply these matrices. The resulting matrix is going to be a 1 by 2 matrix. It's going to have 1 row and 2 columns. So in other words, there's going to be 2 entries in here. The first entry I get by taking this row times this column. So 1 times 2 plus 2 times 1 plus 3 times 3. So that's 2 plus 2 is 4 plus 9 is 13. Then I do the first row times the second column. 1 times 4 plus 2 times negative 1 plus 3 times 0. So that's going to be 4 plus negative 2 plus 0, which is 2. So there's my matrix, which is a 1 by 2. Next one. This is a 3 by 2, and this is a 1 by 3. Because the inner dimensions don't match, I can't multiply, because if I try to multiply this column, or sorry, you don't multiply the columns times the rows, you multiply rows times columns. This row times this column, the number of elements don't match, so this cannot be multiplied. So this is not possible. Okay, last two. if I go through and multiply this, and I'm just going to do this a little more quickly. This is a 2 by 2 times a 2 by 2, which will end up being a 2 by 2. So I have 2 times 8 is 16, plus negative 3 times 5, which is negative 15. This is 1. Then I have 2 times 3 is 6, plus negative 3 times 2 is negative 6. This is 0. Then if I do the second, do that one now, negative 5 times 8 is negative 40. 8 times 5 is positive 40. 0. Negative 5 times 3 is negative 15. 8 times 2 is 16. So this ends up being 1. When you get this special matrix that has a diagonal row from left to right of 1s, and actually maybe I should erase that because that kind of is hard to see. But anyway, you see this diagonal row of 1s from left to right? This is known as the identity matrix. And if you multiply two matrices and you get the identity matrix, that means that these two matrices are inverse matrices. They're inverses of each other. This is going to have this is going to affect what we're going to do with matrix multiplication in just a minute. Now, another interesting feature is and identity matrices are always square. So you always have a 2 by 2, a 3 by 3, or so forth. So notice here I have an identity matrix right here. If I multiply an identity matrix times a matrix, what happens? So I'm going to do those 3 rows times these 3 columns. It's a 3 by 3 times a 3 by 3, so I get another 3 by 3. So I do 1 times 1, 2 times 0, 3 times 0. That gives me 1. Then I do 1 times 0, 2 times 1, 3 times 0. I get 2. Then I do 1 times 0, 2 times 0, 3 times 1. I get 3. Notice that's exactly the same row that I had before. If I do 4 times 1, 5 times 0, 6 times 0, I get 4. If I do 4 times 0, 5 times 1, 6 times 0, I get 5. And guess what? I'm going to just get the same numbers back again. So if you take a matrix times the inverse, or times the identity matrix, I should probably write identity here instead of just I, times the identity, you just get the same matrix. Okay, so that's a little review about matrix multiplication.